Now then, we're in the battery shed, and a little bit later on I want to explain to you the two vagaries of our system and what will work and what won't work, because it'll be interesting for people. I've had various questions over the last year as to, can you take a solar grid inverter and put batteries on it to make it work as an off-grid inverter? And the simple answer is no. That click was just the charge controller. You're going to have to put up with that. It's the dump load for the turbine, and although it's breezy, it's very sunny, so therefore when the battery voltage goes up because of the sun, then the turbine charge controller, which is based on voltage, comes on as well, and there's a big click and it brings in a 25 or 28 amp dump load straight across the turbine. So there you go. It just slows it down or diverts the output. Anyway, what was I saying? You can't use a solar grid inverter with batteries, not an old-fashioned one, because the solar grid inverter needs the mains supply for it to work. It's under the G83 rules. Basically it says if there isn't a main supply, the inverter's got to switch off. Anyway, that's that. So there's all sorts of things. Anyway, the next thing is that, and I've got myself a note here, Peter Ansell was watching my forklift lead acid batteries investigation part 1 and 2. He was asking me about drop testers for batteries. Lead acid batteries are great, they're quite robust, but like everything else, if you abuse it, then start to fall apart. And the best way to renovate batteries that have been slightly abused, like for instance, you'll get one who's, say this is the capacity of the battery, yeah, you'll get one that will fully charge, and you'll get another one that, although the voltage rises to the right amount, it won't charge up properly. And what you need to do on that one is trickle charge it really slowly over the course of quite a while. Like with a forklift battery, you want to trickle charge it for like 2 weeks at say 5 amps or something like that. Okay, and then slowly what happens is that the sulfate part of the chemical reaction comes away from the lead plate. So effectively the lead plates in the battery are cleaned by the trickle charge, but that lead sulfate, the lead sulfate changes into lead and sulfate, and the sulfate joins with hydrogen to effectively make stronger sulfuric acid. So the electrolyte gets stronger and the plates get cleaner, and because the plates are cleaner, it means that there's more reactive area, so therefore it has a greater capacity. One of the downsides is that lead sulfate is larger in volume than the lead itself, yeah, which is natural, and therefore it can, if it gets really bad, start to damage the plates by expanding. Okay, so that's enough of that theory. So drop testing. Okay, if you think you've got problems with your batteries, you need to identify those ones that are misbehaving or haven't got as much capacity, and amongst everything else, as well as a hydrometer to check the specific gravity, yeah, and the voltage, you can use a drop tester. And effectively what a drop tester is a load that you put across the battery and a voltmeter across that load. So effectively you're putting a load on the battery which goes, yeah, I'm drawing loads of current, and then you're seeing what the voltage of the battery does. And if you dump the load on, and the voltage will drop down a bit, but then if it stays level over 2 or 3 seconds, you're not too bad. But if the voltage drops and then goes down over the next couple of seconds, you know you've got a problem with that particular cell. Either you've damaged it, or it's sulfated up and wants to trickle charge. And of course there's only one way to find out, is to trickle charge it. And just, this is the whole thing about looking after your batteries. Lead acid batteries are brilliant, and they're relatively cheap, second-hand forklift batteries, but they are the mad granddaddy, as I've said in my book, of the battery world. You've got to look after them. Yeah? You don't want to draw too much energy out of them. And this is where the rule of don't take more than 50% of the capacity out of your batteries. And you go, how can I check that? With specific gravity. You don't really want your batteries to go below 1150, and you don't really want to charge them above about 1280. So some forklift batteries have had extra acid added to them, and yeah, when the forklift engineer's about trying to get a bit more power out of them. So effectively what happens, and this happened with the pack that was in the video. There was 2 or 3 videos about renovating a pack. When they actually got put in service, the specific gravity gradually rose and rose and rose to about 1380, and we had to take some of the acid out and then put some distilled water in to make the volume up. And sometimes you might have to do that 2 or 3 times, just because the batteries have been messed with at some point. So trickle charging will clean the plates, and it will raise the specific gravity. Enough of that. Okay, hopefully Michael, you've taken that on board. But now we're going to look at drop testers only, and how to make your own drop tester. It's quite simple. It's a dump load and a multimeter across it to read the voltage. Simples, but let's have a look at the ones that I've got here, and we'll mess with them. Okay, here's quite an old one, and the load is in there. It's just a piece of nichrome bar. It is really quite a thick lump. I'm going to zoom in so that you can read what it says on the label. There's quite a lot of interesting details. So if you want to do a screenshot of that, there you go. Okay, and the voltmeter, as you can see, comes around to 2 volts, 1.5, and then at the bottom here there is current. Let's see if we can just zoom in a bit more for that. Okay, so my battery is obviously second hand, came from the scrapyard. They've been I've picked out the real bad ones, and so they're not perfect, but they're good enough. Yeah, so I'm not expecting absolutely brilliant. I would imagine if we came round to about 1.5, 1.6 volts, yeah, which shows charged, that'll do. Okay, hopefully that makes sense. I'll show you a different drop tester. There's the voltmeter. Again, the same sort of thing. Okay. And I'll just turn this round, and there is the load straight across those pins. Hopefully you can see that the meter is across the pins and the load is across the pins. So effectively what you need to do is you need to build something that has got some nichrome wire across it, and it doesn't have to be all in one piece. And in the past I've used the wire out of the old-fashioned, the big square chunky storage heaters, which had like about 1.2 mil nichrome wire in it. Perfect. Several strands of that and away you go. So you can make your own. We'll see if we can make one later on. Okay, let's see it in action. Where have we got? We've got just there, we've got two exposed terminals, and these are four terminal batteries, which means they're designed to give out lots of current. So let's just see how we get on with this. So let's just see what happens. I've put a little bit of oil on the load. There we go, just to show. Hopefully you saw that. Let's just, can we see that properly now? Just about. And I've got my clamp meter. That shows 200 amps. You can't see that. Let's try and see if we can do it again. It's a bit tricky. Oh, that stinks. And we started to melt the... Tell you what I'm going to have to do. I'm going to have to focus on the clamp meter. Let's see if we can zoom down on that. There we go. No, hands in the way. There we go. And we're staying at 1.5 volts. So that's pretty good. Okay. Let's zoom down on the meter. If you can see there, it's staying stationary. Yeah? So it's providing the current, and the load is actually it's starting to smell quite hot, so I'm going to have to stop now. There we go. So the load draws the current, and if the battery can supply the current without the voltage dropping too greatly, you know you're onto a winner. Right, I've gathered some bits together. Okay, now then, there's a battery video that I did a long time ago, whereas I made that, which is nichrome wire and two big brass connectors. Okay, I thought I'd done one, but it's hidden in amongst a load of the battery. The videos might be 6 or 7 years old. Something to do with the battery shed maybe, I'm not sure. Anyway, this is the nichrome wire that I'm talking about. Yeah, I suppose we ought to measure it really. I'll do that in a minute. Yeah, so battery drop testing. Okay, but first of all I just want to show you these things. I bought that donkeys years ago, probably nearly 30 years ago, in a second-hand bookshop, and they did look at me a bit strange when I bought this, but it's wonderful. It's a hardback, and that's where I got a lot of info. the lead storage battery by H.G. Brown. I paid £1 for it, which was a lot of money in those days, and it was printed in 1959, and it's got loads of really good info in it. Right, so whether or not you can find that, I don't know. This one is pretty good, and this is by Lindsay Books, and they're reprints in America. Now, Maximus Iron Thumper, when he was doing one of his best books, or books that I recommend, he mentioned Lindsay Books as far as some of his blacksmithing books were concerned. So this is quite good. It's quite small. It should still be available. Okay. Modern electric practice. Right, this goes into all sorts of stuff, but there's a huge section about batteries in here, and it's old school technology. So it tells you why and wherefore, rather than just wherefore without the why. And of course, the best one, and Max Iron Thumper did recommend this, of course, and because my income's gone through the floor, you can help. There you go, and there's a huge section in this about batteries, and Michael has already got a copy of this, and he was referring to, because he'd learnt about drop testers out of this book, you see, and he was wanting to know how he could make one, because he couldn't get hold of one. So if everybody wants to do the honours, I'd really appreciate that. So there you go, that's where to get some info from. Suppose I better go and get a set of calipers. Back in a minute. So there we go. 1.5 mil. So as I've said, that's nichrome resistance wire. It's not any old wire. Now what we want to do is really want to know what the resistance of this resistance is here. So we'll put the meter onto ohms. I'm expecting it to be not very much. 0.2. That's what that says there. Try somewhere else. With such small resistances, you've got to be very careful to get a very good connection. 0.2. Okay? Because the slightest bit of muck or poor connection, and you're going to get a higher resistance. Which is why the ends of these spikes, contacts, need to be into a sharp point, as the same with your meter. So hopefully you can see that. See, we've got 0.5 now, 0.9, but we're right on the weld there. 0.2. Yeah, because as I say, the slightest bit of muck will give you a wrong reading. Now then, should we zoom down a bit? This here hopefully you can see that. That's right. Now what is the resistance of this block that I made? And again we want really quite a good 0.3. That'll do. Okay, because my meter has got sharp points. And we have 1, 2, 3, 4, 5, 6, 7, 8 lengths of that nichrome wire, and they're approximately 2 inches long. Okay, if we made it shorter, it'd be less of a resistance. We took one out, it'd be slightly more of a resistance. Okay, but that's how I set it up all those years ago. Hang on a minute, the phone's ringing. Now then, mate. Right then, so 0.3 ohms, and we've covered all that there. Yeah. So you just basically, it has to be the right resistance for the voltage of the batteries. If you put that across a 12 volt battery, it would burn out because the wire's too fat for 12 volts, but it's fine for 2 volts. So what we need to do now is, I've got some of these. Where are we? Now these are something to do with displays, some sort of hooky arrangement, yeah, and I just got a load of them kicking around. So what I thought was, that if I put that in there like that and another one in there like that, then I can bend these and grind a point on, and there is the 2 pointers. Yeah, and then if I put a connection onto, for instance, one of these bits of nichrome wire, put a connector block, and then I can put a probe of the multimeter set on DC volts. So I'm going to put that together and then we'll go and test it. Okay, hopefully you can see this. It's a bit rough and ready, and we've got the amp meter, the amp clamp, we're going to put it there, and we've got the voltmeter set on 2 volts. So it's all going to get a bit warm. We've got 170 amps and we've got 1 volt, but everything's smoking like mad. Hopefully you can see that. So you get the theory. Obviously you'd have to tune this a bit, this setup, to get the right sort of load. And of course it's a comparative thing, so it's if you find one where the voltage drops down to virtually nothing, you know that that cell has got a problem. I'm surprised the voltage dropped down to 1 volt. Don't know. Wouldn't like to say. Maybe it's the fact that you're using a multimeter rather than a standard voltmeter. Maybe there's something in the way that the multimeter is sampling the reading, but as I say, it's comparative. If you use a, what's it called, a linear meter as it were, then you'll probably get a different reading. Let's see if I've got one. So I found a couple of analog meters. That one says watts, and there is no label on it to show what the full scale deflection should be. So what do we got? We've got a 1.5 volt battery here. Now considering we want to go 2 volts full scale, yeah, let's just see what happens if we stick the 1.5 volts through this meter. Yeah, it goes full scale like that. Okay, so we don't want it to do that. we need to put a resistor in series with the meter. So I've got a couple of resistors here. Now, unlike Big Clive, who can just look at the colours and just go, oh, it's a so-and-so. I'm colourblind partially, so you know, colours are to me a bit of a mystery. Right, so that's one of those, whatever colour those bands are. Yeah, so let's try that. It still goes all the way over. Hopefully this is making sense. Let's just zoom in a bit more. Okay, so we need to go. This is just some experimental stuff that's been kicking around in my box of miscellaneous assorted resistors. Okay, hopefully you can see that. There's one there and there's one there. Yeah, so now let's just try it again. So we're going through one resistor, through the next. That's pretty good. It's not quite good enough, but it's nearly there. So let's measure the resistance across those two resistors. So we've got the meter set on resistance 2k, and we want to go from there to there, and it is, you can't see, no, you still can't see, there we go. We're going across those two, from there through one resistor and through the next, and it's near as damn it 1.5k. Okay, so that's not quite good enough. Now I've been searching through the box and I can't find anything that is just a bit more, and I don't really want to build a whole trail of resistors. So I've got this one, which is, should be $4K. Okay, hopefully you can see that. So let's try that one. Switch the meter off, get that out of the way so we haven't got lots of things in the background. And remember, we're using 1.5 volts, so and we shall be wanting to read, oh, something like that, up to 2 volts. So let's just see what happens here. That's not bad, that would do. So I'm assuming 2 volts will be sort of up near the 6 volt. So what we can do is we can build that into the drop tester. We can just experiment with this. I mean, you could do it properly with all sorts of nice little brackets and all that sort of thing. But let's just proof of concept and all that sort of thing. Let's go and have a look in the battery shed again. Hopefully that sort of makes sense. It's trial and error. And collections of resistors. And as I say, the colours mean nothing to me, so I have to go through this with a meter and find out what's what. That's quite a rural way of doing it, but if you've got a collection of old resistors like this, it's surprising how it can get you out of trouble, or it can help the experimenting along. So whenever you've got old bits of equipment and they're going to get scrapped, desolder a load of the resistors and put them in a box. So let's have a look. Can I see what's going on? So I put a couple of bits of ash branch as handles on this. Let's see if we're all in shot. That's not bad. Okay, then we've got the meter with these test leads, so let's go across there, and we've got the resistor, and that goes to the other side of the drop tester. This is working better. Wrong way round. Okay. There we go. Can we see the meter? No, we can't. And everything's getting very hot. Really hot. I think we're drawing too much current. But there you go. Can you see we got the idea there? Wow. Hopefully that sorted out any questions about drop testers. And when you're wanting to go off-grid with electricity, or even... No, that's not right. When you want to generate and store home power, then you can either use a modern Powerwall type lithium battery, or you can use lead acid batteries like we have. Yeah, we've got somewhere in the region of 1800 amp hours worth of storage, and at 48 volts, that's a 48 volt battery pack. Yes, there are 20 amp hours to the kilowatt, and you should only ever use 50% of the capacity of the battery pack. So I've got loads of videos about this sort of subject, and I think there's a playlist, I can't quite remember, but there's also a wind and solar playlist. So I'd ask everybody to go back through my playlists and watch the videos, because hopefully it will make some of the issues fairly clear. You've got to look after things, and then it'll look after you. Catch up with you soon. Cheers for now, and what a beautiful afternoon, eh?